Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. This is extended physics, and the code for this subject is 0625. We are today in this video going to attempt a paper 2 of this physics, and we have selected May-June 2023 2 paper. This paper 2 belongs from the zone 2. The total marks for this paper are 40, and the time allowed for this paper is 45 minutes. So let's start this paper. Okay, so here we go. This is the paper which is showing up on your screen. May-June 2023 2 paper, and here we go. The G value in this paper we will take as 9.8 meter per second square. Question number 1 is showing up on your screen. So here we go. Question number 1. Forces of 3 Newton and 4 Newton are act at right angles as shown. What is the resultant force? Okay. So because this is 3 Newton and this is 4 Newton, their tails are joined and the angle between them is 90 degree. So we will complete the parallelogram formed by them. So these are the adjacent sides of that parallelogram. So this X, Y, Z, O, X, that is the parallelogram. So where the tails are joined, you join it with the opposite corner of that parallelogram, and that is your resultant. So if this is 3 Newton, this is also 3 Newton. Because this is parallelogram, so this angle will be also 90. So now you can apply Pythagoras here. If you apply Pythagoras, it will be 4 square plus 3 square, and that will be equals to OY square. So OY will be equals to OY square will be equals to 16 plus 9, and that will be 25. And when you take square root of it, it will be 5. So that means that OY will be 5 Newton, and the resultant will be along the OY. The resultant will be, its direction will be this, from O to Y. This is your resultant. So 5 Newton along the OY. So I think C is the right option, sir. So let's check marking scheme. C is the right option. So C is the right option, sir. Okay. So let's move to the next question. The next question coming up on your screen is question number 2. A light bulb is held at rest at the top of a tall cliff. It is released and falls through the air, eventually reaching its terminal velocity. Sorry, this is not bulb, a light ball. I said bulb. A light ball is held at rest at the top of a tall cliff. It is released and falls through the air, eventually reaching its terminal velocity. Which road describes the behavior of the ball as it descends? The initial acceleration of the ball. So you see, for example, if the ball is released, suppose from here, and it is coming, let's say, suppose here. So the ball will start falling from here. So here, the acceleration will be maximum, and that acceleration will be equals to the G, which is 9.8. And when it reaches terminal velocity, for example, when the ball is here, the velocity becomes constant. The velocity, suppose, becomes constant. This velocity will be called, what do you call it? Terminal velocity. So this terminal velocity, so here the acceleration becomes 0. This is the main concept. Okay. So the initial acceleration of the ball, that will be G. The final acceleration of the ball when it's falling with the constant velocity, which we call the terminal velocity. At that moment, the acceleration becomes 0 because the velocity becomes constant. The resultant force becomes 0. So I think C is the option. Question number 2, I think C is the right option, sir. Question number 2, C is the right option, sir. He says the question number 3, the graph represents the motion of a car. How far has the car moved between 0 and 5 seconds? So it's a speed time graph, and if you want to find out the distance traveled, if a speed time graph is given to you, you can find that distance by calculating the area under the speed time graph. The area under the speed time graph is this triangle. So the area of the triangle is 1/2 base into height. So we can find the area of this triangle, and here we go. The area under the speed time graph will be this is shape of a triangle. So that is 1/2 base into height. So 1/2 into 5 into 10. So it will be 25 meter. 25 meter. So 25 meter is the answer, sir. So I think C is the option here. So question number 3, C is the option. Yes, that's true. Okay, so we are going to the next question. The next question coming up on your screen is question number 4. He says, which statement about mass or weight is not correct? Masses can be compared using a balance. That's true. Mass is a force. That's wrong. Mass is not a force. Weight can be compared using a balance. That is true. Weight is a force. Yes, weight is a force. So their question was, which is not correct? So which one is not correct? The B is not correct, in which he says mass is a force. Mass is the amount of matter in a body. So mass is not a force. So B is the right option, sir. So we are going to the next question, and the next question on your screen is question number 5. It says a sphere P made of steel has a weight of 10 Newton on Earth. Another sphere Q, also made of steel, has a weight of 10 Newton on Mars. The gravitational field strength on Earth is greater than the gravitational field strength on Mars. Which statement is correct? The mass of the sphere P is the same as the mass of the sphere Q. Okay. The mass. Okay. So let's do this. We can calculate this. So you see, the weight on the Earth is equal to the mass of the P multiply the G on the Earth. Weight on the Mars is the mass of the body Q and the G value on the Mars. So because he said, both the bodies have the same weight. Both the bodies have 10 Newton weight. One has 10 Newton weight on the Mars. The one other has 10 Newton weight on the Earth. So let's suppose, means that is given that their weight is same. So we will make their weight equal to each other. So weight on the Earth and the weight on the mass of the body P and the body Q, they both are equal to each other. So MP into GE equals to MQ into GM. Means the mass of the P and the G on the E Earth, and the mass of the Q and the G value on the Mars. Okay. Then the mass of the P divided by the mass of the Q will be equal to the G on the Mars divided by the G on the Earth. You know this G value on the Earth, because these two ratios are equal, and because this G of the Earth, the G on the Earth, is more than the G value on the Mars. This we know that. Okay. So that means the denominator here is larger, the numerator is smaller. So that means that the mass of the Q needs to be larger. So from here, because this ratio is equal to this ratio, because the GE value is greater than the GM value, because denominator is greater, numerator is smaller. So here in this ratio also, the numerator is smaller and the denominator must be larger. So that means that the MQ will be greater than the mass of the P. That means the mass of the Q is greater than the mass of the P. Very technical, very mathematical. The mass of the sphere P is the same as the mass of the sphere Q. No, the mass of the sphere P is less than the mass of the Q. This is what we have concluded there. The mass of the P is smaller than the mass of the Q. On the mass, the weight of the sphere P is the same as the weight of the sphere Q. On the Mars, the weight of the sphere P is the same as, no, if you take both the bodies to the Mars, their mass will be not equal to each other. On Earth, the weight of the sphere Q is less than 10 Newton. Maybe the mass of the sphere P is less than the mass of the sphere Q. About this, we are 100% sure. Question number 5. I think B is the right option, sir. This is a very tricky question. This one is also, but this cannot be true, okay? Because on the Q value on the G value on the Mars is less. So if a body has the same weight as the weight of the P on the Earth, this body mass will be more than the mass of the P. So the good answer, the B part, the mass of the sphere P is less than the mass of the sphere Q. Very mathematical. This is how mathematically we have proven it. And it's a tricky question. Okay, so hopefully you understand. So next question number 6 we are doing here. Okay, so he says, which two quantities must be known to determine the density of a material? To find, the formula for the density of the material is mass divided by volume. So we need to find out the mass and the volume. So I think B is the answer, sir. Question number 6, it's B part. That is right. Okay, now we are going to the next part. Okay, so here we have the next part. Okay. He says a truck is towing a car along a straight horizontal road at a constant speed. So here you see this rope is attaching the truck with the car. So this truck is pulling this car. The rope breaks. This rope breaks. Okay. Which two gives the direction of the initial acceleration of the truck after the rope breaks and the reason for the acceleration? You see, when this rope will break, all of a sudden the load on the truck will decrease and this truck will accelerate in this direction. The truck will accelerate after this rope breaks. Then what happens? This truck accelerates. So the direction of the acceleration of the truck, that will be towards the right. And the reason is the load on the truck has decreased suddenly. So, or you can say the resistive force have decreased. So the truck will accelerate to the right. So C and D option. The driving force is greater than the resistive force on the truck. Yeah, the driving force is smaller than. So C is the answer, sir. Because he said that truck will accelerate to the right. The reason is that the driving force has now become more than the resistive force. Before, the truck was going with the constant speed. So the driving force and the resistive force, they were equal. When the rope which was connecting the truck and the car with each other, that breaks, all of a sudden, the resistive force on the truck decreases. So the driving force obviously becomes more than the resistive force. So I think question number 7C is the answer, sir. Question number 7C is the right answer, sir. Question number 8 is on your screen, and he says, okay, he says a uniform beam is pivoted at the center and two identical masses X and Y are placed so that the beam balance, a smaller mass is then added at the position shown. Okay, so this whole thing is in balance, and all of a sudden what you have done, you have put a small mass here. How can the masses be positioned so that the beam balance again? So now the anti-clockwise moment would have become more than the clockwise moment. So to to counter this anti-clockwise, increased anti-clockwise moment, you have to move this y little to more towards the right. So this anti-clock, so the what happens if you move the y little towards the right? So what will happen? The moment arm of this will increase and the clockwise moment will increase. Move x away from the pivot, no, that will increase the anti-clockwise moment, which will not balance it. Move x towards the pivot, that can help a little bit, yes. Move y towards the pivot, that cannot be, that will decrease the clockwise moment. Move the small mass away from the pivot, no, that will increase the anti-clockwise moment. So the best answer they have given is move the x towards the pivot. You see, if you will move x towards the pivot, what will happen? The moment arm of the weight of this x will decrease. And due to this, the anti-clockwise moment will decrease. So then they might become equal to the clockwise moment. So I think question number 8, B is the answer, sir. Question number 8, let's see, B is the right answer, sir. This is a little tricky question. Okay, now we have the next question. The question number we have on your screen is question number 9. And he says a resultant force of 2 Newton acts on an object of mass 3 kg for 6 seconds. What is the change in velocity of the object? We know the force, we know the mass, we know how much time that force acted. And their question is, what is the change in the velocity? If you know the force and you know the time for which the force is acting, that is impulse. And once you know the impulse, the impulse is equals to force multiplied time. Another formula for the impulse is change in the momentum. So we know the mass, so we can find that change in the momentum very easily. You see, so impulse is equals to change in the momentum. Okay, so force multiplied time, that is equals to mv minus mu. The force is 2 newtons and the time is 6 seconds. And the mass, we can take the mass common. So that is 3 kg mass. And in the bracket, you are left with the v minus u, that is the change in the velocity. So 12 divided by 3, and that is equals to the v minus u. So v minus u will be equals to 4. So the change in the velocity is 4 meter per second. This is how we used force, time, mass to find the change in the velocity. So 4 is the answer, sir. 4. Okay, 4 is the answer. We have here the answer 4, and that is C option. Question number 9. C is the right option, sir. Okay, now we are going to the next question. That is question number 10. The diagram shows the energy stores for a mobile cell phone and how the energy is transferred. So the chemical energy by something will be converted into internal energy, kinetic energy. Internal energy means heating, and the kinetic energy, for example, sound is given. What describes how the chemical energy is transferred? Electric work done, mechanical work done, electromagnetic waves, sound waves. So electrical, I think that electrical work done. The question is, what describes how the chemical energy is transferred? By the battery, by the electrical system. So I think A is the option. Question number 10, A is the right option, sir. Okay, question number 11. He says a wind turbine is 30% efficient and has an output of 2.5 megawatt of electric power. What is the power input to the turbine? Okay, So the power input to the turbine will be, and you know the formula for the efficiency is that efficiency is equals to the useful output power divided by the input power multiply 100. Okay, so from there we can calculate this. It's an easy peasy question. Efficiency is equals to useful output power divided by the input power multiply 100. Efficiency is 30%. The efficiency is 30 means is equals to the useful output power is 2.5 x power 6 watts. Mega means raised to power 6. 10 raised to power 6, I mean. Input power is question multiply 100. So the input power will be equals to 2.56 x power 6 multiply 100 divided by 30, and that will be 8333333.33 watt. That means 8.33 x power 6 watts. So 10 raised power 6 means mega. So the input power is 8.33 megawatt. 8.33 megawatt. So I think B is the option. Question number 11, B is the right option, sir. Then we have question number, question number 12. So question number 12 is showing up on your screen. Which two physical quantities must be used to calculate the power developed by a student running up a flight of steps? You know, the power, the formula for the power is energy divided by time, or you can say the power is work done divided by the time. So he says force exerted and the vertical height of the steps only. No, that is force exerted and the time taken only. No, the work done and the vertical height of the steps only. No, the work done and the time taken only. For power, I need to know the work done and the time taken to complete that work. That is power. Power is equals to work divided by time. Question number 12, D is the right answer, sir. Then we have question number 13 coming up on your screen. So in the question number 13, he says, the density of the seawater is 1030 kg per meter cube. The gravitational field strength on the earth is 9.8 Newton per kg. The atmospheric pressure is 101,000 Pascal. At which depth in the seawater is the total pressure due to the atmosphere and the water is equals to 513,000 Pascal. You know, the total pressure under the water will be the pressure due to the atmosphere plus the pressure due to the water. So the pressure due to the water, the formula is rho GH. Rho GH, where rho means the density and G means the gravitational field strength and H means the depth of the liquid above the point of observation. So here we go. He says the total pressure is equal to the pressure due to the water plus the atmospheric pressure. The total pressure is 513,000 Pascal, and that is equals to the pressure due to the water is rho GH, and plus the atmospheric pressure is 101,000 Pascal. So take this 101,000 Pascal to the other side, it will subtract from 513,000 and you will be left with 412,000 Pascal. So 412,000 is equals to rho GH. The value of the rho of the seawater is given, that is 1030 kg per meter cube, and the G value is 9.8 Newton per kg, and the H, the depth of that liquid water, is questioned. So H, make that H alone. So you will, this 1030 will go on the other side, it will divide, 9.8 will go on the other side and it will divide there. So you will have 412,000 divided by 1030 divided by 9.8 equals to, that will be 4.8, you can say a meter. So sorry, I said 4.8, this is 40.8. 40.8. Let's check the answer. Do we have that answer? Yes, the A part is the answer. 40.8. So question number 13, A is the right answer, sir. Our answer is right. This is how this has been done. So let's go to the next part. Okay, the next question coming up on your screen is question number 14. He says, four students describe the phrase absolute zero during a lesson on the particle model. Which student is correct? This is the lowest possible temperature. Yes, when we study the, the Charles law, there they say the lowest possible temperature is 0 Kelvin, which is called absolute zero. So that sentence is right. Particles in a solid start vibrating. The particles of the solid are always vibrating. Particles do not have any weight. This is not true. Particles have the least gravitational potential energy. That is also not true. The only sensible sentence here is A. This is the lowest possible temperature. Question number 14. A is the right answer, sir. Okay, so we are going to the next question. That is question number 15. And in the question number 15, we have, he says, four students are asked to state and explain the relative magnitudes of the thermal expansions of solids and gases. Which student is correct? You see, the gases expand more than the solids. Gases expand more than solids because the molecules in a gas are in random motion. B option is the gases expand more than solids because the attractive force between the molecules are much weaker in the gases. So I think B looks the best answer to me. Solid expands more, that is wrong. Solid expand more than gas, that is totally wrong. C and D is totally wrong. From A and B, the B looks much better because there is very, very negligible force of attraction between the molecules of the gas. That's why they expand more and more. So question number 15, I think B is the right answer, sir, and it is the B. B is the right answer. Okay, so we are going to the next part. That is question number 16 on your screen. He says four cups A, B, C, and D contain hot coffee. Which cup keeps the coffee warm the longest? That cup will keep the coffee warm longest, from where the heat lost is a minimum. So how the outside surface of the cup, to reduce the heat loss, the outside of the cup must be white, and the top of the cup, to stop the heat loss by the evaporation, if you cover it with a lid, then it will lose a small amount of current, of heat, sorry. So white color, the outer surface should be white, and the top of the cup must be covered with the lid, and then that cup will keep the coffee warm for the longest time. So I think white and covered with the lid. So I think question number 16, C is the answer, sir, and that is right answer. Okay, now we are going to the next part. That is question number 17. In the question number 17, we have here, okay, so here we have the diagram shows a wave. Okay, so from the mean position, how high you go, that maximum thing, the high you went, that is called the amplitude. And the distance between the two consecutive points who are in the same phase, that is called the wavelength. So the wavelength, which is represented with the lambda, that is 8 centimeter, and the amplitude here is 3 centimeter. So the amplitude is 3 centimeter and the wavelength is 8 centimeter. What are the amplitude and the wavelength of this wave? So 3 is the amplitude and 8 centimeter is the wavelength. So I think B is the best answer given here. Question number 17. B is the right answer, sir. Okay, so here we are on the question number 18, and it says, in the question number 18, it says, optical fibers are used to transmit digital signals using infrared radiation. The average refractive index of the fibers is 1.50, which row describe a digital signal and gives the speed of the infrared radiation in the fibers. You know, the one thing is that the infrared radiation, its speed in the vacuum or in the air is 3 expo 8 meter per second. In the fiber, the speed, because the fiber is solid, the speed will become a little less than that. So that can be not 4.5 expo 8, it must be 2.0 expo 8 meter per second. So either the answer is A or it is C. So the digital signal, you know, the digital signal has only two values, 1 and 0, 1 and 0. So a digital signal that consists of only two values. So A is the right answer, sir. Digital signal has only two values. If you have studied computer, or you might have heard, it is either high or it is low. It is either 1 or it is 0. That is digital signal. So question number 18, we say A is the answer. A is the right answer, sir. Okay, so we are going to the next question, and that question is question number 19. He says, which statement describes monochromatic light? Monochromatic light means a light which has only one color. So it will have a single frequency. Means that color will have obviously a single frequency. Light of a single frequency, light transmitted by the transparent prism, no. The visible light, no. White light, no. So white light consists of 7 colors, you know. So monochromatic light is that light which has only one color. So its frequency has, there is only single frequency light in that. So question number 19, A is the answer, sir. Question number 19, A is the answer. Okay, now we are going to the next part. He says a beam of light. He says a beam of light. Okay, so here we have question number 20. A beam of light consists of yellow and blue light. The beam of light is incident on a glass prism. Which diagram is correct? Okay, so when the light passes through the prism, and its refraction will take place, and a band of colors will be formed, and the order of the colors in is Roy G. Biv. So we say Roy means red, orange, yellow, green, blue, indigo, and violet. So the yellow will be up and the blue will be below the yellow color in that spectrum. So either the A is the answer or the B is the right answer. Second thing is that when this light enters into the prism, you see, when it enters into the prism and you draw here a normal. Let me try to draw a normal here. So what happens? This light, when enters into the prism, the speed of the light becomes smaller. The light slows down. So what happens? It should bend towards the normal, not away from the normal. So A cannot be the answer. So D is the right answer, because when you draw a normal here, for example, let me draw a normal here. So the light has bended towards the normal. So this is the right refraction. This is the property of the light when it enters into a medium which is more dense, optically dense, I mean. So what happens? It bends towards the normal because it slows down. So D is the right answer, sir. So question number 20, let's check. D is the right answer. Yes, the question 20, D is the right answer. Okay, so now we are on question number 21. He says a radio station broadcasts a signal with a frequency of 89 megahertz. What is the wavelength of this signal? So, because you know the signal's speed is speed of light, and that speed is 3 × 8 meter per second, and we know the frequency 89 megahertz. So, by using the wave equation V equals to F lambda, we can find the wavelength of this signal. So, V is equals to F lambda. And, the V is 3 × 8 and F is 89 × 6 hertz and lambda is question. So, lambda will be equals to 3 × 8 divided by 89 × 6 and the answer will be 3.4 meter. So, the answer is 3.4 meters. So, I think B is the right answer, sir. So let's check question number 21. B is the right answer, sir. Question number 22 is on your screen. A boy shouts and hears the echo from a tall building 2.2 seconds later. The speed of the sound in the air is 330 meters per second. How far from the boy is the building? So you see, for example, here we have that building. Suppose this is that building. So that boy is here somewhere. So that boy is here. So he produces that sound. And what the sound will do, the sound will go there. And then this sound will be reflected and it will come back. It went and came back. It took 2.2 seconds. We know the speed of the sound, so I will multiply the time with the speed of the sound. That will be the distance covered by that sound wave in going and coming back. So the distance between the boy and the building will be half of that distance. So let me tell you this. Let me show you. Okay. So distance covered by the sound wave will be speed multiplied time. The speed is 330 meters per second and the time is 2.2 seconds. So that is 726 meters. But the distance between the boy and the building will be half of this distance. So that will be 726 divided by 2 and that is 363 meter. When you round it off, it's 360 meter. 360 meter. Do we have that answer, sir? Yes, C is the right answer. So question number 22, C is the right answer, sir. Okay, so we are going to the next question. That is question number 23. Here we have, he says, okay, so here we have a magnetic field of a bar magnet can be represented by the magnetic field lines. Which diagram shows two magnetic field lines correctly? From the north, the magnetic lines comes out, and in the south, the magnetic lines go in. From the north, the magnetic lines come out, and in the south, the magnetic lines go in. So I think A is the best answer, sir. From the north, the magnetic lines are coming out, and in the south, the magnetic lines are going in. Question number 23, A is the right answer, sir. Question number, we have 24. A plastic rod is rubbed with a dry cloth. The rod becomes positively charged because the rod has become positively charged. Why has the rod become positive charge? The reason is when you rub the rod and the cloth and the rod becomes positively charged, that means it has lost electrons. It has lost electrons. So I think C is the best answer. So very simple, straightforward question. Question number 24, C is the right answer, not a difficult one. Okay, question number 25. He says, which statement about the electric current in a conductor is correct? In a DC circuit, the electric current gradually decreases along the conductor. That is not true. In a DC circuit, the free electrons flows back and forth. No, The free electrons flow back and forth in the alternating current. In an AC circuit, the electric current remains exactly the same all the time. No, no, that is not right. The electric current is changing. It's changing. Sometimes its value is increasing, then decreasing, then increasing, then decreasing. And the direction of the electric current is also changing. It do not remain same all the time. In an AC circuit, the flow of charge change direction continuously. This is the best sentence which can describe an alternating circuit. So question number 25, D is the right answer, sir. Question number we have 26. He says a piece of metal wire X with a uniform diameter has resistance R. A second piece of wire Y is made of the same metal and has a uniform diameter. Y has double the cross-sectional area of the X and half the length of X. What is the resistance of the Y? So its cross-sectional area is double and its length is half the length of the X. So what will be its resistance? Because both the wires, they are made of the same material, so they both of them will have the same resistivity. So rho 1 is equals to rho 2. You know the rho 1, that is R1 A1 by L1, and the rho 2 will be the R2 A2 by the L2. Let me say that the first resistance is R, and the resistance of the first wire is cross-sectional area of the first wire is A, and the length of the first wire is L. Now the second wire's resistance is question, and the cross-sectional area is 2A, double the cross-sectional area of the first wire, and its length is half. So if the length of the previous one was L, the now its length will be L by 2. So A and A will be cancelled, L and L will be cancelled. So R2 will be equals to, when this 1 by 2 will go upstairs, it will become 2 by 1. So R by L will be equals to 4R2 by L. L and L cancel. So R will be equals to 4R2. So the R2 will be R by 4. So the resistance of that second wire will be 1/4 of the resistance of the first wire, R by 4. Okay, so R by 4, do we have that option? Yes, A is the answer, sir. Question number 26, A is the right answer, sir. That is true. And this is how we have done that. So this is question number 26, and A is its answer. So let's go to the next part, and that is question number 27. He says an electric fire is connected to a 240-volt supply and transfers energy at a rate of 1 kilowatt. How much charge passes through the fire in 1 hour? Okay, now the voltage is given, the power is given, and the time is given. You know the power is equals to IV, because the power is equals to IV. From there we can find out the current. So power is equals to IV. So 1000, 1 kilowatt power means 1000 watt. So 1000 is equals to I multiply 240. So the I will be equals to 1000 divided by 240, and that will be 4.17 ampere. Now I is equals to Q by T. I is equals to Q by T. So Q is the charge, I is 4.17 ampere, and T is 1 hour. So it will be 3600 seconds. So Q will be equal to 4.17 multiplied 3600 second. So it will be 15,012. So it is 1.5 x per 4 coulomb. 1.5 x per 4 coulomb. 1.5 x per 4 coulomb. So I think C is the right answer, sir. Question number 27, C is the right answer. Okay. The next question is question number 28. He says, two lamps are connected in parallel. Which switches must be closed so that both the switches light? Okay, so we have to close this one. Okay, We also have to close this one. We also have to close this one. So you have to close S1, S2, and S3, all of them. So I think which switches must be closed so that both the lamps light? So I think D is the option. Question number 28, D is the right option, sir. Okay. So, okay. So now we are going to the next part. That is question number 29. Okay. So once again, I am on the question number 29. So in the question number 29, he says the diagram shows a circuit that switches on a lamp when there is a change in the environment. So here we have a thermistor, so its resistance can be increased or decreased by changing the temperature. So if you want this switch to be closed so this lamp can be lit, so what you have to do, you have to increase the temperature. When the temperature will increase, the resistance of this thermistor will decrease. So the voltage drop here will decrease. Then what will happen? The voltage drop across this fixed resistor will increase. So this will become a stronger magnet and it will attract this toggle and this switch will be closed and this lamp will lit. So what you have to do, you have to increase the temperature. When the temperature will increase, the resistance of this thermistor will decrease. And I think an increase in the temperature. So this is a potential divider. Hopefully you have studied it. Question number 29, I think D is the right option, sir. Question number 29, D is the right option. So we are going to the next part, and the next part is question number 30. Here we have. He says a step-down transformer is 100% efficient. It has an input voltage of 240 volt AC and an output voltage of 60 volt AC. The current in the primary coil is 0.50 ampere. What is the current in the secondary coil? So the voltage in the primary coil is 240 volt and the voltage in the secondary coil is 60 volt. So what the current in the primary coil is 0.5 ampere. So what is the current in the secondary coil? Very easy peasy question. You see, Vs by Vp is equals to Ip by Is, and the voltage in the secondary is 60 volt, voltage in the primary is 240. The current in the primary is 0.50 ampere, and the current in the secondary is question. So the current in the secondary will be 0.5 multiplied 240 divided by 60 and equals to, and that will be 2 ampere. So that means 2 ampere. So do we have that answer here? Yes, sir. C is the answer. Question number 30, C is the right answer. Okay. So we are going to the next question. That is question number 31. He says the diagram shows the pattern of the magnetic field due to the current I in a straight wire. Which row is correct? Direction of the field. Because the current is going downward, so what I'm going to use my right hand grip rule for the straight conductor. We are going to use the right hand grip rule for the straight conductor. So what you will do, you will hold this, you do it yourself because the current is going downward. So hold it in your right hand, your thumb must be along the direction of the current. The curls of your right hand are actually showing the direction of the magnetic field. That means the direction of the magnetic field will be clockwise. So the direction of the field must be clockwise. So the correct direction of the magnetic field is shown by the Y. So the relative strength of the field, as you will be close to the coil, to the wire, sorry, that field will be stronger, that electric field will be stronger. But as you move away from the wire, that field, that magnetic field, sorry, I said electric field in my sentence, it's magnetic field. So the magnetic field will become weaker. So at P, the magnetic field is weak. At Q, the magnetic field is strong. So greater at Q and then the P, and the Y is the correct direction of the magnetic field. So greater, so I think D is the right answer, sir. Question number 31, D is the answer. So let's check. D is the right answer, sir. Okay, so we have here question number 32. He says, in which device is the magnetic effect of a current not used? Okay. Electromagnet, it uses the magnetic effect of the current. Loudspeaker, it uses the magnetic effect of the current. Potential divider, it do not use. Relay, it use the magnetic effect of the current. So in the potential divider, we do not use the magnetic effect of the current. So question number 32, C is the right answer, sir. I hope you know what is electromagnet. I hope you know what is loudspeaker and what is potential divider, what is relay. So now we have question number 33. In the question number 33, he says, fission and fusion are two types of nuclear process. How does the total mass of the nuclides produced compare with the total mass of the original nuclide or nuclides in these nuclear process? Total mass of fission product compared to the original nuclide, it should be smaller. The mass reduces, that mass converts into energy actually. So the total mass of the fusion product compared to the original nuclide, that also becomes smaller. So in both the cases, the total mass of the product is less than the mass of the original nuclide in both the cases. So less. 33 is D option. That is right answer, sir. That mass which disappears, that converts into energy according to E equals to mc square. Hopefully you understand. Question number 34. He says the table shows the composition of three different nuclei. So nucleus, number of protons, number of neutrons are given. Which nuclei are isotopes of the same element? Those are the isotopes of the same element who have the same number of protons in their nucleus. Okay, so three protons, protons. So they are the same. They are the elements of they are the isotopes of the same element, because you see their number of protons are same and number of neutrons are different from each other. So they are isotopes of the same element. So X and Y, X and Y, X and Y, X and Y. So B is the answer, sir. Question number 34, B is the right answer, sir. Okay, so that was question number 34. Now we are on the question number 35. He says, which change occurs in the nucleus of a radioactive atom during beta emission? You see, when a beta particle is given from a radioactive isotope, the daughter nucleus, one proton number increases in it and one neutron number decreases. The nuclide number, the number of, the mass number do not change. Proton number increases by one, proton number increases by one, the neutron number decreases by one. A neutron transforms into a proton and electron. That is the 100% true fact. A neutron transforms into a proton only. No. A proton transforms into a neutron and an electron. That is not right. A proton transforms into a neutron only. If you read what happens in actually when the beta emission happens, a neutron in the nucleus breaks and it converts into an electron and a proton. So that's a fact, a very famous fact, that 35A is the right option. So question number 35, A is the right option. Okay, so we are going to the next part, and in the next part he says a radioactive isotope, that's question number 36. A radioactive isotope has a half-life of 8 days. A detector close to a sample of this isotope gives a count rate of 200 counts per minute. Without the source, the background count is 20 counts per minute. What is the count rate due to the source? What is the count rate? What? Due to the source after 8 days. That means one half life would have passed. Okay, so this is the reading which was originally coming, you detected on the detector. So it is the count rate due to the source plus the count rate due to the background. The background count rate is 20 counts per minute. So first of all, from 200, I will subtract this, and then, okay. So the count rate on the detector is 200 counts per minute. Then the reading due to the sample originally will be, from it subtract the background radiation. So 200 minus 20, that is 180 counts per minute. So when one half life would have passed, there were originally the count rate was 180. After one half life, the count rate will become half. So after 8 days, it will become, from 180, you half it, it becomes 90. So 90 counts per, and this is pure reading due to the sample after 90 days. So 90 is the answer, sir. This is the reading due to the sample. Okay. So this is the answer. So question number 36, B is the answer. Okay, so we are going to the next part, that is question number 37. Okay, so he says, which statement about the solar system is correct? All planets are rocky? No. The first 4 planets are rocky, rest of the planets are gaseous. Only the Earth has a moon. No. Other planets also have moons. They have more than one moon. Pluto is a dwarf planet. That is true. There are many stars in the solar system. No. So C is the right answer. Pluto is a dwarf planet. Okay, that is C answer. Question number 37. C is the right answer, sir. Then we have question number 38. Comets are bodies which orbit the sun in the solar system. What is the shape of the orbit, and how is the shape of the orbit of the, this is the shape. Okay, this shape is called elliptical. So the shape of the orbit of the comets is elliptical, and the sun is here. This point is called the focus. This is called the focus of the elliptical. There are 2 focus of the elliptical. One focus is here and the one focus is here. These 2 points are called, this is focus of the elliptical, this is focus of the elliptical. So that means the sun is not at the center of the orbit. Okay. So the orbit of the comet is elliptical, and the position of the sun is not at the center of the orbit. This is at the focus of that elliptical orbit. So I think D looks the best answer. Elliptical, and the sun is not at the center of the orbit. So 38, D is the answer, sir. Question number 38, D is the answer. I hope you know this is called focus. This is called focus. The sun is on one of the focus. Okay, so question number, we are on 39. He says, which nuclear reaction produces the release of energy to power a star? On the stars, the process of fusion is taking place. And normally what happens, the hydrogen and hydrogen atoms fuse into each other to make helium. That is the nuclear reaction happening. So nuclear fusion of hydrogen into helium. So I think 39D is the answer. Question number 39D is the right answer. I think this is a fact and you should know it. And then we have question number, this is question number, which question this is? This is question number 40. He says, what is the definition of the Hubble constant? You remember the Hubble constant, which is represented with the H naught, and its unit is 1 by second. That is equals to V by D. Okay. V means the speed and D means the distance. Is the ratio of the speed at which a galaxy is receding from the Earth to its distance from the Earth. This is the definition of the Hubble's constant. And it's a fact. You should know this. Question number 40A is the answer, sir. And that is good. Okay. So we are done with this paper. My dear students. So this video is complete. In this video, we have done the solution of the May-June 2023 2 paper. So I have tried my best to write the answers, to describe the answers, so that this video can be helpful to you, so that you can understand it. If still unintentionally, if I have made some mistake, I am sorry for that. I'm a human. It's possible that I might make an error. But you see, if you think that this video is useful for you and this video is beneficial for you, please subscribe to my channel. Please like this video. Please share the link of this video on your WhatsApp groups, on your Facebook account, on your TikTok, on your Instagram story, on your Snapchat, wherever it's possible, please share it. Because you see, when you share the story, the link of this video, you help me to promote my channel, and that's a big support for me. The main theme of these videos is to provide help to the students around the globe who are studying Cambridge O levels, and obviously this video will help some IGCSE students as well, to make their life little easier, their parents' life easier, their teachers' life little easier. Now they can sit in their home just by watching a YouTube video, they can practice this question. So thank you very much for watching my video and practicing your physics with me. So it's a great blessing for me. So thank you very much once again. Have a good day and God bless you all.